Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about types of hybrid drivetrains. So let's dive deep into it. Now, I'm reasonably sure you must have heard this term hybrid way too many times and way too many drive options are available. So let's try to figure out scientifically what the hell is going on. So first, why do we need this sort of hybrid drivetrain? Well, reality is there are few things happening. First is fuel prices are gone up drastically. It does not matter who you are, does not matter which country you live in. You have realized that fuel prices are going up, and including crude oil prices. Now, be mindful, crude oil prices have way too much volatility, and that's why even if crude oil prices are low, government generally like, let's keep the price stable. It's better to have a stable price. And again, when it suits up, it does not directly translate into your money going up, because again they try to tamper it as much as possible. And another aspect is, even if crude oil is super cheap and your country does not know how to run its economy and it has miserable control over inflation, yeah, you do not run your cars on crude oil, you run it on petrol, diesel, gasoline, or whatever have you. And yes, I know they are the same thing, but you get the point. It's going to be costly. And if you compare that price, petrol and diesel prices are going up drastically, meaning at this point in time, we have to pay 100 rupees per liter around for petrol right now in India. Now, be mindful, when I was a kid in schools, I used to remember it was only costing 40 to 100, and it's not even 50-60 years old. Like, it's only barely 2 decades old. So that is the dangerous part. It's going up fast. And what does that mean? That simply means right now, whatever the price you are paying for fuel right now, by the end of your vehicle life that you just bought right now, let's say you bought a car in 2025 and you're going to retire it in 2035, you're going to be maybe paying almost 2x, especially if you are in a country that does not have good inflation control. So it's a very painful realization for people to realize that fuel is expensive. It's no longer that stable era. It's going bonkers era, and the price are going lol. So it's dangerous. Another aspect is pollution. Now, pollution is becoming a significant public threat, especially for densely populated metropolitans like India's uh, Delhi specifically. Unfortunately, Delhi is surrounded by such a landlocked area that it has like very bad air quality. So it's a serious issue worldwide, and it's bad. Let's be very clear. Everybody agrees to that. Everybody knows it's bad. We do want to make sure that is as low as possible. The only way to do that, which is for certain, is like burn less fuel. The end. That's the only way to do that. So these two are something that everybody will agree with. Another is global warming is also becoming a concern. Whether you agree to it or not agree to it does not matter. Assume the first two matters. If you agree to it, okay, assume this also matters. So global warming also matters. And be mindful, even if you may not agree to it, your country's government may apply policies, so that could create an issue. So that's the whole point. Now, what does that mean? That simply means we all need a lower fuel consumption. That's all we want. We want our cars to run on as little fuel as possible. Now, we have been developing ICE engine, internal combustion engine, be it petrol, be it diesel, be it kerosene, be it whatever else. We have been working our ass off for 1 century. Why the heck it's not efficient? Well, it is very efficient. It's drastically more efficient compared to what it used to be. But problem is, no matter what you do, whatever engineering you do, there will always be a efficiency island. Now, island has risen up drastically how it used to be. We were barely getting 10%. Now you can easily get commercial cars, commercial vehicles, commercial as in like just person buying it, that has 30 or even 35%. Some are even touching 50%. But generally those are big container ship engines. But you get the point. Like, we are making amazing progress. There is just one problem with that. You cannot actually utilize it. It's like, well, why? Well, it's the efficiency island paradox. Meaning, if whatever manufacturer you have, it does not matter, Honda, Toyota, whatever have you, no matter which engine you take, it will always have a XY coordinate, meaning at specific RPM, at specific torque loading, you're gonna get the most thermodynamic efficiency. And that's it. The moment you change the torque loading, it goes down. The moment you change the RPM, it goes down. Now, that should have triggered a red, green light bulb in your brain. It's like, oh, that's why even though my car claims the mileage of like super duper high, and especially if you have a car that has a dash of real time mileage, the number sometimes goes very high. Yeah, if you are in that efficiency island, number would be stupidly high. It's just that you can't stay there. If you have a gearbox, you can't stay there. The RPM will float, the torque loading will float, your wind will affect it, the grade will affect it, road condition will affect it, everything affects it. So it's nigh impossible for basically engine to stay in that island. World would be drastically different if every engine could stay at the island. If we can just stay at the island, and again, it's the efficiency island is mapped by what we call brake specific fuel consumption. So for example, to give you some context, if you are running at sweet spot, for example, this engine, 250 grams of fuel would be combust and you're gonna get 1 unit of electricity. Cool, awesome, GG. Here's the deal. What if you go flow rate? You're gonna go turbo Tokyo drift on it. Yeah, you may be consuming 600 gram to make one. Yeah, that's the problem. Even though it's the same vehicle, let that be the same engine block, nothing has changed. It's just that parameters have changed. Your combustion efficiency has gone to the gutter. So that's why staying at the efficiency island. Inherently, that's what we try to do with gearbox and CVT and all that jazz. It's still too goddamn difficult because not only you have to lock the RPM, you also have to lock the torque loading. It's difficult. So that's the core problem. That's why we need it. We need to reduce fuel consumption. But again, engines have reached a paradoxical limit. Fuel prices are expensive that people are willing to try random things. Pollution has become a big issue. And global warming for some 50% of humanity is a big deal. Now we come to the joke technology, which we call mild hybrid. And yeah, if somebody came up with the idea, what if we had a small motor generator unit in your vehicle and it does regenerative braking? You have to realize regenerative braking is a really awesome technology, and you can recover upwards of 30 to 50% of energy that you spent in acceleration. And if you are talking about city stop and go traffic, that's a lot of energy that you can recover. So, and again, it will also make sure that your brake pads do not wear that quickly. So what if we can use that? What if that will also allow us to do quick start? Basically, you are stop at the traffic sign, and that time is the worst time for your engine because engines need certain level of RPM for some useful torque. And if you are pressing it, it has to burn way too much fuel to jump from very low RPM. Let's say 0 RPM to it has to jump to 50, then try to as quickly as possible to jump to 700, 800 RPM, so it has useful torque so your car can move. And many times engine are oversized just for that limitation. So when you press the accelerator, it does not need to go from, let's say, 0 RPM to 7,000 RPM so you can move. It can do that at, let's say, 1500 RPM. These are what we call overscaling. And same goes other way also. For sometimes trucks generally have ludicrously oversized engine, not because you need that much power, but simply because when you do need to overtake or you do need to go on top of a ramp, it does need a lot of power. So quick start and stop and torque assist at lower RPM. That's the biggest weak link of basically the engines we have. So this idea first time brought into the market by Honda Insight in year 1999. Ancient technology, and in Indian market it was released by Maruti Suzuki by Cras model that was released in 2015. Again, older technology. Now this is a joke technology because what it does is it replaces the motor generator unit with instead of having alternator and starter, you throw both of them away, you put integrated motor generator starter. Now if you're like, okay, why the heck it has a belt? Yeah, that's the part I do not get. Somehow in Indian market we have scooties like two-wheelers that has like integrated motor and starter, no belt, is directly on the flywheel. Same happens in high-end cars, luxury cars from BMW, Mercedes, they have integrated that. We have belt driven in Toyota, Audi, and basically Maruti for some reason. And the idea is this has a secondary battery box. Now secondary battery box is different compared to your normal lead acid 12 volt. Secondary battery box are 48 volt lithium ion. Now and again, the year when it was released at 99, the time it did not have lithium ion, that time it had nickel metal highlights. So idea is that at starting your engine, it will drain the energy from that 48 volt and push your car from that 0 RPM issue. The motor is like, I got you. I will not require you to burn excessive fuel because at that dead load scenario, I am the best. It takes years of it. Once you have enough RPM, it's like, I got this. Engine takes over. And how do you charge it? Because there is no plug, no charger. You cannot charge it. Every time you apply brakes, it does that. And again, some of them also utilize, because again, it is the car's alternator. It has enough energy to, like, just to leach a little bit. And generally they are a bit more efficient because they are brushless. So most of them have permanent magnet rotor, so they are a bit more efficient. It can leach off enough energy without reducing your mileage, that it can give you 48 volt battery full charge without any issue. Now it's just a joke. It's too little. Basically that battery is tiny, and that started from, because again, if you understand torque dumping by a belt is like, why? Like, again, you can do it. It's just that why? and impact is very little. And again, there's been there in every company has something like this, but it's joke. It's just joke, and it's very expensive for what it is. Like the fuel saving is so little. It's like, what if I just threw away that 48 volt? What if I just threw away that? It will save more. And again, if they had 48 volt, they have not even upgraded the car electronics to be 48 volt, like steering pumps, the windshield motors, wipers, pumps, all of that. If they all of that has was 48 volt, which again sooner or later we have to do, it would be much better, because again you reduce the copper content of the car and you will get weight savings. We are not even doing that. Throw away the 12 volt battery, that will give you weight saving. You are not even doing that. So it's literally almost every scientific journal I'm looking into it, the effect is negligible at best, and worst case scenario, it wear down your engine very quickly, because again, start and stop is bad for engine. You do not want your engine to go going start, stop. And if you're in city traffic, this will do that. It will start and stop way too often, and a penalty of that is the engine block that could easily last for 10 years will poop itself in 5 years. So it's a joke technology, really not recommended. And if you have to buy it, don't pay for it. As in, like, if you like, if somebody is giving you for cheap price, go for it. If not, don't bother. Like, again, nobody actually likes this idea. It's mild hybrid. Why? Then we come to strong hybrid. Because of the mild hybrid BS, we have to name this strong hybrid. Now, this is a full electric vehicle. Let that be very clear. This can drive properly. There, it can just give you some torque asset. If you just try to run on that 48 volt battery, your car will not go very far. So there, it can actually run on it. And in some scenarios, some vehicles, it can go upwards of 100 km per hour just on motor itself. So it is a full electric vehicle with ICE engine, as an electronic internal combustion engine, driving a generator. So at low speed, it's fully electric vehicle, meaning till 50 km per hour, you are literally driving a system that is just running on motor generator number 1. That's it. You are driving an electric car, but engine is on. Now, what is engine doing? Engine is spinning the motor generator number 2 as a generator. Now, be mindful, when you are running a generator and it's an independent generator, as in like you can control how much load it has. You can let the engine go into that efficiency island. It's like, hey, what RPM you want? Engine is like, bro, put me at 2500 RPM. It's like, okay, generator is going to rotate at 2500 RPM. Bro, put me at this torque loading, whatever, 100 Newton meter, let's just say. It's like, okay, only draw that much amp that it matches to that. Perfect efficiency, and you're getting the most amount of energy from that fuel that you're burning. It's going into your battery bank. Now, these battery banks are bigger. These puppies go up to 200 volt. So these battery banks are generally bigger. It's generally below at the bottom seat. So that big battery bank absorbs all the energy. Now, how you're driving it? Well, here's the deal. When you're driving it, your load requirement is variable. You could require a lot of torque. You could require a lot of speed. Motor generator 1 is like, I'm doing this. And battery is acting as a buffer. It's literally like a river has a fixed flow. You have a giant reservoir and a dam. Dam is controlling how much electricity is generated, because again, country during daytime may have higher requirement, at night time low requirement. But again, river has constant flow. You do not let it directly. You control the gates, but you need some buffer. Battery is the buffer. This allows the maximum efficiency utilization. That's why we do that. At high speed, it bypasses all of that. At high speed is just like, okay, drive it. So basically, if you go into flyover and like you're going ring roads or like, cruising at full speed, then it's like, okay, bypass all of this, directly couple it. In Honda, coupling happens is almost like a 5th gear on a static transmission, where it's like at overspeed. It only connects when it's doing overspeed. It does have a clutch. It wajangs it, drives your wheel directly at overspeed. And that's why you still need variable valve timing. Now, topology wise, this topology is classified as series parallel hybrid. So it can run in series, because again, when you are running this as generator, it's not mechanically moving the wheels. It's series. It's just creating electricity going into the battery driving the motor. Now, you may be like, how the heck that could be more efficient? The transmission is not efficient. Generation is efficient, meaning instead of, let's say your transmission loss was 5%. Now it has increased to 10%. But yes, your engine is now 15% more efficient, because again, now you're keeping the engine at efficiency island. That's why it's justifiable. That's why people do it. Let that be very clear. Transmission, even if you're losing energy in transmission, but your engine is working far more efficiently, and because fuel will not come back, that is the most precious consumable in your vehicle. If you are utilizing that properly, you will go much further because of this topology. That's why people did that. and generally it behaves like e-CVT, electric basically is constantly variable transmission. And how they are doing it is almost what we call power split device, or it's technically planetary gearbox, where you can control all things. Basically you control the sun gear, you can control the carrier, everything can be controlled and counter rotated to give you smooth range. Basically it's CVT without the sleepiness or the elasticity that people hate when Nissan does it and all that. So it gives you the full SUV level torque, it gives you the oomph, the torque of that. And here's the deal: if you are like, okay, you set it to sports mode, it can drive all three: combustion engine, motor generator number 2, motor generator number 1, all of them in one go, all of them. Basically at that point your torque would be, basically your SUV, Toyota SUV will fly like a Ferrari for short duration. So that's the whole point. People love, like, this puppy is torquey, and when you are doing in city traffic, it has smooth, it does not even have that automatic transmission where you can almost feel that it has gear. No, this is like smooth. So people like that. Now, and it also allows engine downscaling. This was the biggest thing that you will see without this transaxle. Toyota making the same, almost same chassis. It's like the engine is 2 liter. With this, it's 1.5 liter. It's like, why did you downscale it? Well, you don't need it. You need that 2 liter because, again, if you're trying to pull it from dead stop, you need a lot of torque at lower RPM. This was like, motor is like, bro, full torque, 0 RPM, go. That's why people went through this. Now, when you combine all of that, the horsepower becomes stupid. Like, you can get almost 3x the horsepower. 2x is default. Like, you can just at launch mode, you can just get 2x the horsepower. And this technology was first time introduced in the market by Toyota Prius 1997, ancient technology. And you're like, wait a minute, if this is works, gives so much advantage, why the heck this does not become the main thing? Like, why the heck not all Toyota has this? Yeah, this puppy is complex AF. I have linked 2 amazing video, one from this and another from Amazing Professor. Try to understand it. Try to understand it, how the heck this works, and be mindful. There is another aspect that you have to understand. I keep reminding this: physics, engineering, economics. Economics of this is very complex. As in, like, how many gearboxes you have, as in, like, this planetary gear system. It may look simple, but you also have to understand, you have to machine a crankcase that can handle that. You have to design bearings places. You have to design, these motors are not super cheap, and they have permanent magnet. And yes, they have permanent magnet from 1997. Expensive. So all of that you have to put motor rotor, and you have to put a super complex vehicle control unit. Everything else is easy. The vehicle control computer is bonkersly complex. It literally is trying to manage 3 puppies constantly. It's like, should I drive this, should I drive that? And if you're trying to do reverse and a clutch is not synced, it has to overdrive this just so you can reverse it. It's like, it's weird beyond belief. It's super complex, and the parts count is very high. So, and again, the R&D cost also, company cannot just give you it for free. Even if the BOM cost after engineering, they have made it very low, they have to recover the cost they went into R&D. So it's super duper hyper expensive. Again, that's why it's on 5th generation right now. And again, it's a good technology. Like, it almost solves all the problem. It's just that it's not KISS. It's not keep it simple silly. It's like very complex, very convoluted, and it does have very small battery, meaning you cannot just charge the battery. And battery wise, it's only designed for few minutes of operation. It's like, okay, go from basically standstill to at some speed, then the engine will kick on. Because again, this is supposed to be running most of the time, topping up the battery. You cannot have a plug for the charging of the battery. So strong hybrid, good technology has been built. It's an awesome driving experience. It's just the penalty is like, it's not KISS. It's too complicated, too convoluted. Like, the driving ratios are like, overdrive this, counter drive this, to do this, to do that. It's like in clutch packs and this, and it's too cumbersome. But it does work. Let that be very clear. The technology does work. It's how somebody just realized, what if we added a plug to it? So take that tiny battery that is generally 200 volt, yeet that away, put instead of nickel batteries, put a lithium batteries, scale the voltage to, let's say, 400 volt. Ta-da! So now you have lithium battery and give the ability to charge either by fast charging or by onboard charger. Onboard charger meaning it can take AC to DC. It will take AC, convert it to DC, charge the battery. DC fast charging simply means it just ta-da, DC. So that can be done. Now, topology, what you can buy in is basically same thing: series parallel that you discussed earlier, or series. Series only is far more simpler. Now, it allows smaller battery. The biggest penalty of basically battery electric vehicle is battery itself. Again, you have to understand the electric drivetrain. People are like, okay, now we have the, no, we had it. 1997 we had it. Actually, we had it in 1907. If you wanted a motor that can like really drive the things, yeah, diesel locomotives, submarines, diesel submarines. We have the motor technology is like, bro, I've been there. I've been there. You're like torque. I've been there. I am the definition of torque. So let that be very clear. If you are like drivetrain wise, electric drivetrain will kick ass and take names of any combustion engine ever made, including jet engines. That's how powerful these puppies are. It's just the battery part sucks. So when you are talking about, like, let's say this is a hybrid system, you can see the battery is not that big, so it's a component rather than the battery bank with wheels. When you compare this design to full battery electric vehicle where you do not have engine, this whole base plate is basically batteries, which is expensive, very expensive, and penalty of that is it's very heavy also. So that's why people are starting to jump into plug-in hybrid. The idea is we have already developed the technology. What if we just made the battery bigger and put a charger on it? And the cost is lower than full battery electric vehicle. Why? Because again, battery is the most expensive part. If you shrink the battery, cost goes down drastically. So that's the whole point. And it's a bridge technology between both electric vehicles and internal combustion engine. So that's why people talking like, oh, hybrids are making comeback. Yeah, that's why. Hybrid is one of the best technology we could have ever built. And if we properly had hindsight with this, we would have always went with series hybrid when we went into battery. Series parallel makes sense for a combustion engine, but if you really want a battery drivetrain directly, series makes far more sense. Less component count, so you do not have like, why the heck this has not become mainstream even though we have been making from 1997? It's like, yeah, it's expensive. So what can we expect in the future? Well, reality is we do need better transportation. Whether you like global warming or not, accept it or not, does not matter. You do give a damn about fuel cost. You do give a damn about pollution. So in those sort of scenario, we do need something that has less pollution and less operating cost, operating expenses. So fundamentally, we both agree on this. And full EV drivetrain is the best. If you are having discussion about the load, I want that, the oomph, the torque. It's like, if you want that vibration feeling, that's a different thing. That's a different thing. Completely agree with that. That's just like feeling. It's like songs. Some songs resonate with you, some songs does not resonate. But in terms of drive quality, speed, velocity, efficiency, torque, everything, electric drivetrain is the best. The end. But battery is the weak link. Now here's the deal. You have to understand, it does not matter the technology. The battery issue was there when lead acid was used. Battery issue was there when nickel metal was used. Battery issue is there when lithium ion is used. It will always was, is, and will be. It's a law of physics. And let that be very clear. I'm giving you an ominous warning that if somebody figured out to make 10 times more energy dense, you may not want to ride on that. Because here's the deal, this batteries generally by their own design carries the both part of the component. Anode and cathode are almost like a closed loop reaction, meaning any failure will result, boom. These things, that's why we cannot put them out in the fire. Like you can put out petrol fire, you can put out jet fuel fire, you can't put out the fire on this because it has both component. When it has fraction of the energy, increase the energy content, that fire will become instead of a whoosh event, it will be a kaboom event. So trust me, under known laws of physics, you do not want to ride on a battery that is like 10 times more. Carbon nanotube batteries like ultra hyper dense. Yeah, any oops event will translate to kaboom event. So under known laws of physics, and given the fact that battery does not get lighter when you want to increase range, that's the penalty. Like worst example would be Hummer EV. That puppy has 1.5 ton battery. Drivetrain is lightweight. Drivetrain is featherweight nowadays. We can make powertrain that is like electric drivetrain, same weight as the transmission case. 6-speed gearbox. At the same weight, we can give you a drivetrain, complete drivetrain. That's how energy dense we have right now, motor drivetrains. Weight is super easy in terms of EV. It's just the battery is stupendously high. And again, same goes with Tesla also. Even though they only had like 33 unit battery, 33 kilowatt hour, then they scaled it up to 55 unit watt hour. In some Indian manufacturers have like 75 unit watt hour. I'm like, damn. And that's the law of physics. So you're like, oh, what if we go into sodium? It will be worse. And trust me, every element in periodic table has been tested. We know what batteries can do. Only thing we are fixing is basically the electrolyte to casing efficiency. That's the thing that is the biggest bottleneck as of now. Basically, how much casing material you have versus how much electrolyte you have. So technology will not solve in the future. We're gonna have solid glass batteries, and trust me, the paper that I'm seeing, and if it actually has that kind of energy density, one accident will translate into boom, greater events. So That's there. Now, what is 1 century teaches us in internal combustion? It does not like variable load. No combustion engine likes variable load. You want combustion engine should not require variable valve timing. It should be like, bro, design it for this RPM, remove everything else just for, let's say, 1500 RPM. You want parasitic loss to be low, keep the RPM low. You want torque to be as high as possible or as efficient as possible. So just design the generator to be loaded to that number, which we can do, which we are surprisingly good at that. You can control the RPM and torque loading precisely. And that way you get best of both worlds. Meaning you're going to have a combustion engine. This is from rotary engine that Mazda is utilizing. This is from other companies. These are some OEMs. They are adding small systems. BMW kind of messed up this amazing technology known as BMW i3. Technology was super amazing. They just have to poof the artist to design the chassis. It's like, who the heck designed that? It looked horrible. And BMW outsourced the range extender on that. What the heck, BMW? Like, you really were cutting cost on that, where you're like, okay, let's outsource that. And it was a really bad engine. It's like, so basically you're driving this super amazing car, super awesome system, everything is awesome. The range extender kicks on. Let's say you are driving very low, range extender kicks on. It's like, it's like, what the hell? They really chipped out on the wrong thing. And again, design made sure that it does not appeal good. Range extender made sound so bad. It was like, it looked cheap. So felt cheap also. Again, Mazda did put a lot of effort to make sure that range extender, when they kicks on, it feels like smooth. So you want that, like you have to put some effort into it, because if people are going from smooth, you have to understand, because there is no constant noise of a combustion engine, any noise will now scream too much. So range extender does require some effort to put into it, especially in terms of noise, vibration, harshness. All of that has to be there. Now, range extender, as in series hybrid, basically you do not put like planetary gearbox, you do not put any sort of a power split device, just an electric drivetrain, a small battery, and a range extender. Because even though everybody opens their mouth, it's like, I need range, I need super hyper range. No, you don't. I need fast charging. No, you don't. 90% of the time, you're going to charge your vehicle at your garage at night, and you're going to go from your house to office to school to this sort of things. Those will be very limited in distance. Why? Because if you live in a city, traffic will not allow you to go very far. And if you live in a suburb area, you're really not going to send your kids to, yeah, my kid has to drive 7 hours, so he goes to a school. No. So realistically, most of the time, you do not have to need giant battery. Even only this much will take care of 90% of the. What if in those times, combustion engine is there? So 90% of the time, you do not worry about fuel cost. And those times when you do have to consume fuel, you are doing it most efficiently as possible. Efficiency island. So that's why range extender is the best electric vehicle that is possible. 90% of the time, you do not have to worry about it. And those times when you do have to worry about it, you do not get stranded. So it's the best technology solution. And again, it will not change. It's like, what if we change the battery? Or like, only thing we are changing is just basically how the electrolyte to casing efficiency. You're not going to get much better than lithium ion. Like, we have tried almost every element in periodic table, including some radioactive ones. So yeah. So future is this. We have to add range extender. We have to reduce the battery, and then everybody can win. Otherwise, everybody's like, yeah, electric nobody buys because it's so goddamn expensive. And again, petrol nobody can afford because it's so goddamn expensive to run fuel-wise. So this was my presentation on basically the drivetrains options that are available right now in the market. Hopefully you have learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.